CloudDB, shaping your new normal.
Hi everyone, full disclosure, this is actually a pre-recorded session. The reason is we are having some dramas with the latency between Perth and the event, and therefore the problem was I didn't want you sitting there waiting 10 seconds every time I press next slide for me to catch up and have the audio out of sync, etc. But I'm here in the Q&A in the chat, so I'm here live, but just if you have questions, throw them in the chat and I'll answer them. But hopefully you enjoy this and hopefully there's no latency issues. On with the show. Welcome everybody. My name's Connor McDonald. I'm a database advocate for Oracle Corporation. This is probably the easiest way to get in touch with me. I love talking technology, so if you want just sort of casual tech conversation with maybe the occasional hint of sarcasm, follow me on Twitter at Connor_MC_D. If you like your tech content in a bit more longer form, perhaps fleshed out a little bit more with more demos, etc., then you can catch me on my blog, connormcdonald.com. And seeing as you're watching a webinar, this would presume you're comfortable with video. So if you like video for your form of tech, check out my YouTube channel as well. We're just about coming up to about 500 videos now. So there's plenty of stuff out there for just about everyone. And also, so I can claim to be up there with the cool kids, if you want all my other mechanisms of getting in touch, email, social media, etc., there's a QR code there. Simply scan that and it'll take you to Linktree, which has all the mechanisms you could ever want to get in touch with me. This is what I do most of the day. I look after the asktom.oracle.com website. Many of you will remember Tom Cart, who retired in 2015. Myself and Chris Saxon have taken over the reins since then. We're just about coming up to, I think, almost 25,000 questions answered now. It's a testament to the quality of the Apex product, really. That site was written way back in the year 2000, and we've been through every Apex upgrade since then with virtually no dramas. Whilst many people are familiar with asktom.oracle.com, some people aren't familiar with this. This is our office hours initiative. We realized a long time ago that there were huge amounts of expertise inside the Oracle Corporation that don't have the luxury of my job. My job is obviously reaching out to you as Oracle customers or anyone interested in Oracle technology. Unfortunately, we have a lot of people inside the organization who have incredible minds when it comes to particular product areas inside the database area, but they don't get that luxury of seeing customers or meeting customers that frequently. So we decided we'd put together this initiative where they would make their time available at least once per month or thereabouts to actually host like random Q&A or deliver content to you. So if you're looking for information on, say, the optimizer or in-memory or text or globalization, etc., we've got product experts who host these sessions. Because we have so many product managers inside Oracle, we're generally looking at about 2 to 3 of these per week. They're all recorded, they're all captured, you can view them on YouTube as well. So yeah, it's a really good initiative to get you better access to information. And of course, it is 100% free. We're not going to spam you. There's no cost. There's no etc. You simply register and we'll simply let you know when office hours sessions are coming available. If you've seen office hours and you think, oh, that's pretty cool, but the topics don't really apply to my particular company, reach out to me. We can actually put together office hours sessions with tailored content and run them privately for your customer. So it might be just your development team or your IT team or your architects. We can give you advice. Once again, it's not going to cost you anything. It's just our emphasis is really making you more successful with the Oracle database. One last little plug before we get into the content. I started a podcast this year, and so if you're interested in a different form of tech content with obviously no demos, no slides, no nothing, just me waxing lyrical for 20 or 30 minutes into a microphone, you can check out my podcast at, you can get it, as they say, wherever you get your podcasts, Spotify, Apple, etc., you can all get it there. The latest one was a series of 3 episodes I did with Tim Hall, or you may know as oracle-base.com, just talking about the state of tech in the world and where we think it's going. Now, before we begin, one of the things I've been saying on every talk I've been doing this year is this. As much as I enjoy doing virtual content and the ability for that virtual content to reach lots of people, places I perhaps would never get a chance to visit, I think all of us are now clamoring to get those stronger bonds of community back. And that comes from obviously face-to-face events. So I would love, even if it was just people, local to Australia, I would love to be able to actually be back in touch physically with people and actually, networking with them, talking to them, having that much more relaxed and probably better community feel. So please get yourself vaccinated, follow your local guidelines, follow your local laws, but let's get ourselves out of this pandemic cycle, out of Deltas, Omicrons, or whatever we want to call them, because I think ultimately, if we can get our communities back, I think 2022 is obviously going to be looking up based on the heartache we've had over the last 2 years. In particular, shout out to all the user groups involved. User groups have done it very hard the last couple of years. And so, hopefully get yourself vaccinated and we'll be back in touch face-to-face next year at a user group near you. So why talk about external tables? External tables aren't some breathtaking new piece of functionality. And in particular, probably this is a good little chance to have a little quiz for you. I've grabbed this little screenshot here from the Oracle Wikipedia page, and it's got the sort of a set of versions. When do you think external tables, the ability to query from a flat file, came into existence? Was it 12.1? No. In fact, we have to dial the clock all the way back to Oracle 9. Yes, 20 years ago. You can think of this talk as being a 20-year anniversary of external tables. This is how long they've been around for, which obviously means they're a very robust technology, but I think they probably haven't been used as much as they could be. And for the rest of this talk, I'm going to present a series of tips and techniques which I think will inspire you to actually look at external tables once again and look at them in terms of perhaps more interesting use cases rather than just getting access to flat files outside the database. So let's kick it off. And for the rest of this session, we're just going to cover these little tips and hopefully you'll find some useful nuggets in there. I want to talk about perhaps what I would call the original problem with external tables. And there's no inherent problem, but what I mean by problem is that they generally weren't adopted with a great gusto when they first came out back in Oracle 9. And the original problem was they were touted as a replacement to SQL Loader, which indeed they are. But let's explore why SQL Loader perhaps held on to its reign as the Oracle external data loader, even though external tables came along. SQL Loader is a very cool piece of technology, and in particular, SQL Loader was always easy. Now, I've put the easy there in quotes because anyone that's looked at a SQL Loader control file sees something like this and sort of goes, that definition of easy perhaps is a little bit loose. And in particular, even if you are fluent in SQL, because SQL Loader syntax or the control file syntax was something just a total departure from a normal SQL, it took people a long time to learn it. But the reason I still insist that SQL Loader was easy was for this simple reason. If you went back to the old versions of the Oracle documentation, going all the way back from 9.2, I think, all the way backwards, no one actually ever read, in my view, the SQL Loader documentation except for the last appendix, which was the SQL Loader case studies. These were awesome because the vast majority of SQL Loader requirements could be almost classified as to these examples. It was effectively, you either had fixed width data, you had comma separated data, you had maybe a little bit of free format, you had some, for example, different character sets data, or you had some data that perhaps wrapped over multiple lines. But that was pretty much the gist of it. That was pretty much all the options you could ever have to worry about. And all you did was you never wrote a SQL Loader control file from scratch. You simply grabbed these case studies and simply worked your down list. Do I have fixed format? Do I have variable length width? Do I have something else? You simply went down and found the one that was closest to your requirement, and then you simply started with that. Even better is once you finally found the one that you were interested in, like I've grabbed one here, which is a variable length data. It gave you a sample control file, which you would simply grab out of the documentation, cut and paste it into your favorite notepad or textpad editor, and then start with that. And then simply change the values. But more importantly, with each line in the control file, we actually gave you an annotation. So just under that control file in the documentation, was these annotations saying that number 1 is, this, that, and the other, number 2 is this, number 3. So it literally walked you through every single line on the control file. So you had a starting point and you had a good description as to what you would need to change to make it work on your system. This is why I say that SQL Loader control files have always been easy, because 99% of your requirements are covered in these case studies and the job is done. There is no better development paradigm than cut, paste, done. If you ever want to know why Stack Overflow is so popular, there's your reason. So what happened after 9.2? Once we moved on to version 10 of the documentation, and external tables were now effectively probably best described as the preferred direction going forward in terms of accessing external data, we removed that section. That section disappeared from the documentation. And so that critical element, the ability to literally cut and paste a almost working example, disappeared. This was actually wrapped up in the fact that the entire sample schema methodology, the fact that we had sample Pro C programs, Pro Fortran programs, Pro COBOL, sample schemas, etc., all got shifted onto what we call in those days, the examples CD, a separate CD of all the information. So it got removed from the documentation because it got moved elsewhere and got replaced with this, the external tables documentation. But I think we missed an opportunity there, or we missed realizing that it wasn't just the documentation that killed us, it was the fact that people could no longer cut and paste those trivial examples. Because now, once we get to this moment when we can no longer do that, when it came to building external tables, we didn't have those case studies to build on. So this is what most of our experience was like when we started trying to build external tables. I run this here and it basically says this, that, and the other. I'm creating an external table. It's got just a couple of columns. I'm getting it from a directory called temp. It's going to be an Oracle Loader, which is pretty much always going to be the case. There's my access parameters. It all seems simple enough. And I get an error. And early iterations back in the Oracle 9 days, the errors, I happily will admit, probably weren't the absolute best. In the example here, it says I have a missing right parentheses. So let's explore that a little bit further. Well, those two parentheses there, yep, they match up fine. They match up fine. The outermost ones match up fine. The next one's in under access parameters. That matches up fine. And so do the list of fields. All the parentheses are all there. So what's going on? Well, this is a bit of a problem because this is the kind of error message that people were unhappy with when they started playing with external tables. It turns out that you need to swap those two lines and then everything's fine. And obviously that's not particularly intuitive, which leads to frustration. Now my table is created, and this leads on to perhaps the next criticism that people had of external tables when they were trying to get them running, is with a SQL Loader control file. You type it in and then you run SQL Loader and it tells you if the control file is valid or not. With an external table, that validation process is predominantly done when at runtime. In a similar metaphor to SQL Loader, you only find out at runtime. Unfortunately, of course, with DDL, we normally expect the opposite. We normally expect a DDL, if it says table created, that DDL is totally fine. But in this case, it's not. Let's see what happens when I try run or query that table. I run select star from my external table. It was table created on the previous slide, and I get this rather cryptic set of errors, which once again adds to frustration for developers. Now, if I hone in, it says, yep, I had an error on line 4, column 12. At least it's given me exactly where the error is. So I can go back to my DDL and say, yep, line 4, column 12. What on earth is going on there? Line 4 doesn't even have 12 characters. So how did it go? This is one of those oddities that came out with external tables. What it was actually doing is telling you had an error in a particular section of your DDL. In particular, it's saying that it was actually the access parameters section. Now, how do we get line 4, column 12 out of that? It's a little bit obtuse. First of all, we skip the bracket. So we start at line 10 there, and we start counting. So that's line 1, that's line 2, that's line 3, and there's line 4. So emp no number is actually line 4 from an access parameters perspective. And then we move along to column number 12, and it says, oh yes, you've used the term number, and that's the error. At which point, developers are still frustrated because they're sitting there going, hold on a second, number's fine. But you need to remember, if you compare this back to SQL Loader, the data types you specify in the field descriptions are a representation of what's coming on the external file, not Oracle data types per se. So we're saying that we have an external integer coming in, hence the term integer external. None of this, of course, would have happened if you had done SQL Loader, because you simply you would have started with this by simply cut and pasting the sample studies. And that's why SQL Loader is still deemed as easier than people who are getting stuck in the early quagmires of external tables. But finally, we got our table created again, we run our query, and guess what? It still fails. So what's going on there? Well, by that stage, I've discovered that most developers simply gave up and said, you know, screw it. I'm just going to write some insert statements. I'll go grab this file in Excel, turn it into insert statements, and just load it like that. Or I'll upload it using Application Express or SQL CL. They just got frustrated with external tables. As it turns out, in this example, if we have a look at this, I wonder if anyone can spot it. It's relatively straightforward. It's just one of those things that doesn't jump out at you because of the somewhat cryptic error message. It actually turns out that you don't specify the path name, you simply have to nominate the file name itself. And in fact, I can even see that's not going to work for me because I got a typo. As I was trying to highlight that in orange, I've lost the leading quote. Let's assume the leading quote is there. But yes, at that point, finally, you will actually be able to run your queries. Now, if SQL Loader is so cool, as I said before, and easy, maybe SQL Loader can help us when it comes to the intricacies and idiosyncrasies of external table DDL. Because one of the very nice things in SQL Loader is we can use SQL Loader not to load data, but to actually give us the external table DDL. Let's see how that works. If I've got a control file, and I can build a nice simple control file, I can use the parameter or the command line parameter, external table equals generate only. And what that does, it says, here's my control file. And I may have written this from scratch, or I may have simply cut and pasted it from those old case studies, something to get me close to where I need to be. When I run that, SQL Loader is not going to actually load the data at all. In fact, you don't even need that data file. I've got, infile dummy.dat there. That file doesn't exist. I don't even need that file. All I need is the control file definition. External table equals generate only will then write the following into the SQL Loader log file. The first thing it gives you is a full external table definition. And it chooses some names, which obviously aren't that particularly impressive, but all I probably need to do is edit those things. I need the external table name, maybe choose the directory that's probably appropriate to me, but all the rest has been done for me, and it's a completely correct DDL. And in fact, you can see it's got a lot more information in it than the normal DDLs we would just whip up if we were typing, because we're normally lazy and concise as developers. But we can see here in this way, it's going to give me a completely working correct DDL for an external table. All I need to do is just change the names and I'm then good to go. So using SQL Loader is still a really useful thing to do, but not for loading data. It's really useful for actually getting the external table DDL. And obviously, if you're migrating from SQL Loader to external tables, just grab all your existing control files and slap them through this command line parameter, and you're pretty much good to go. I should note that things have got a little bit better over the versions. We took on board the fact that people were suffering under these error messages and cryptic outputs from external table errors. And so if we look at those previous two examples, nowadays in, say, Oracle, I think from 18 or 12 above, you run this and you'll actually tell you the bad identifier was number. So in that example where we had integer external and we incorrectly put number, at least now we get told what the bad identifier was. In the one where I had the path name in the file name, same thing. We actually add a little bit more to the error message now, and you'll get something like this. File name cannot contain a path specification, and it gives us that. So I must admit, we've done a lot of work now to try and make the external table error messages better, such that you can have a bit more confidence building them from scratch. But I still believe there's a place there for SQL Loader in terms of whip up a little control file or grab one of the sample control files, playing it through external table equals generate only, and you're pretty much good to go. It's not lost on me the irony that SQL Loader is ultimately designed to be replaced or obsoleted by external tables, and yet it's SQL Loader that provides the best facility to generate the DDL for external tables. It's almost like trying to put yourself out of a job. But funny enough, when it comes to DDL, the easiest DDL when it comes to building external tables is no DDL. Now, that seems a bit strange. Obviously, every table has to have a DDL, or does it? External tables actually don't need DDL at all. And the reason I think that can be a useful sort of weapon to have in your arsenal is nothing to do with DDL per se. It's the fact that there are often cultural issues associated with DDL. Now, to explain what I mean by cultural issues, let me walk through a demo of what I often see in the workplace in my many years of working with Oracle technology. I have an external file that I wish to expose as an external table, and I build myself some DDL. There's the first part of the DDL. In this case, I may have generated it with SQL Loader, external table generate only, and there's the next part, and it creates fine. It all looks fine, and it actually will work fine. The DDL is correct. The only drama with that DDL is what happens if there's just one bad record, something that doesn't meet the formatting rules of my external table definition. This is what happens when I query my table. It simply says reject limit reached, because by default, a single reject is enough to simply abandon your entire query with the DDL I showed before. Now, generally, I'd imagine that one row out of God knows how many is probably not a big deal. And at least they're captured in the bad file, a log file, so you could probably get away with that, or at least be able to track it. And there's an easy fix. All I needed to do in my DDL was add reject limit unlimited, or choose a sensible number like 50 or 100, something by which I'm not prepared to go beyond, and I would have been good to go. But of course, that's DDL. And generally what happens is when you want to change DDL on a live system, that creates all sorts of angst. And the reason it does is DDL falls into that concept of significant change. And don't get me wrong, that's probably rightly so. If I want to drop a column, add a column, that can obviously be a significant undertaking. But the most common reason that we have is that causes all these dramas is what I call ITIL. ITIL stands for, I think, Information Technology Infrastructure Library. You may know it as service calls, change records, etc. It's the set of processes under which we try to make changes more robust and add some more rigor to them. But it also means, from a developer's perspective, they often view that as just, that's a lot of red tape. And so let me walk through what generally happens when you find that you forgot to add reject limit, say 100 on your DDL, and you think, no worries, this is a no-brainer. It's like a few characters to add to the DDL. I just drop and recreate the table and we're good to go. This is what happens in real life. You raise a service call. That service call then goes to the help desk. The help desk raises a problem record. That goes to the escalated to the problem review board. They go through it and they'll give it to the app support manager, who gives it to a project manager, who then logs a defect. That becomes a task in Jira or an issue. That goes to the team lead, who gives it to developer. Developer has to write a script and a backup script in case something goes wrong. That all goes into change control. QA comes along, gives it to the config manager, who bundles it up, becomes a service call to make an installation to test. Test raises a change request, which then goes to the change approval board. They approve the change. They say, oh, what if it creates a problem and brings our website down? It goes back to the change approval board. They say, better do this after hours when no one's on the system. At 4 a.m., probably in 6 weeks' time, you finally get to do your change. Now, I don't want to be sitting here and be like saying I'm crapping on ITIL. ITIL actually is a valuable part of any organization, but this is the kind of perspective we often get from developers. Such a simple change, even because it's DDL, becomes a huge drama. In 12.2 onwards, we made some strides in terms of improving this. So if you're on 12.2 and above, you can actually change some of the components of an external table definition at runtime. So I can do select star from that external table before, and then add this external modifier, and then add another clause. So in this case, that missing reject limit clause, I've simply added on with the external modifier command, and voila, my query now works. It no longer fails. So this is a useful thing to be able to do, to take slight components of the external table and be able to modify them at runtime. In particular, if we looked at that first external table definition I had, this is the file name in there. Now, when we look a bit closer at that file name, it doesn't take a lot of rocket science to think that file name is definitely going to change, because the file name looks like YYYYMMDD. I'm guessing that tomorrow we're going to get a new file name. Probably that's the 10th of 1st of October. So tomorrow that'll be the 2nd of October. Rather than have to redo the DDL or do an alter table to change the location, you can simply select from table external modifier and change the file name. That's very useful because that can be turned into a bit of dynamic SQL, and you simply dynamically build that query each time you want to pick up today, tomorrow, next day's file. These are the things you can change, and there's a lot of them, with external modifier. You can change the default directory in case you have different directories for the files coming in, different location, the access parameters even, so you could actually multiply some of the field definitions, and the reject limit. So this is all available from 12.2 onwards. In 18C, we sort of looked at this and thought, if you can change the access parameters in particular, there's pretty much not much you can't. You're almost rejigging the whole thing from scratch. So why bother with DDL at all? We have this thing called the zero DDL option, which I think is a very nifty way of being able to access flat files now anywhere just with a query. The definition is pretty much unchanged. So if you've been using SQL Loader generate only or generate table to get an external table DVL, that'll be useful still. But now the entire DDL, for lack of a better term, goes inside the select statement. The way we let the database know it's an external table definition is we do select star from external and then brackets and then almost the entire definition of the external table. The column names, the access parameters, all the normal stuff, just right there in the query. Therefore, no DDL is required. That can go straight into your application code. Don't get me wrong, I think DDL is still useful because DDL is a nice sort of statement of record of the definition of the objects you're trying to query. But what this new syntax does make available to you is you could, for example, if you're in an organization where doing DDL on tables is a big deal, but maybe just changing a view is not such a big deal, you could now create a view which effectively mimics the external table DDL definition, because I'm just doing select star from external. So lots of options there, but in particular now, the ability to directly access external sources without having any DDL. You simply just write a query, I think is a very, very useful tool going forward when it comes to accessing external data sources. It's been long documented that the fundamental benefit of external tables over SQL Loader is the power of SQL. With SQL Loader, there's obviously a little bit of flexibility when it comes to using things like the when condition, etc., to customize the incoming format into a target table. But obviously you get nothing even remotely close to the power of SQL. However, I'd like to talk about external tables not in relation to the flexibility of SQL, because that, believe it or not, is underselling the abilities of external tables. Because external tables have this one advantage where you can actually have more flexibility than what the SQL language offers you. Let me explain. This is the thing that probably drives external table adoption. Here I have an external table called external_emp. It's just reading from, say, a CSV file. But obviously with SQL Loader, normally you'll just have to load that data in. An external table lets you do things like aggregations, group bys, etc. And that's all part of the wow factor of external tables. But when I say we can do even more than what conventional SQL would allow, let's explore an option here. Let's assume we want to query the database alert log. That's a nice example of an external file source that we might want to query inside the database. Now, a quick segue first. This used to be a classic external table example. you wanted to give an example that everyone could do. The alert log's on every single database, therefore we will do it. However, you should not query the alert log with an external table, even though that's the demo we're about to do. Let me explain why. In all the recent versions of the Oracle database, we already give you a query that lets you query the alert log. In fact, you can see it's $diag alert external. We've now exposed the alert log via a $dollar view. This is critical, obviously, for those environments where you don't have operating system access, things like cloud environments, etc. The ability to query the alert log is critical to DBAs, therefore we've exposed it via a $dollar view. And you can see all the columns are in there, all the parsing has been done for you. It's actually more than an external table, because if you run this query, for example, inside a pluggable database, then you'll only see the alert log entries that pertain to that pluggable database. So it's not just a internal external table. It's not just an external table under the covers. It's more than that to do all the appropriate parsing and control access via the appropriate level of privileges. So you wouldn't ever build an external table to query the alert log. I'm going to do it now just to demonstrate some points. So assuming we're querying the alert log as an external table, this is what I would do. First, obviously, I need a directory that points to where my table is. So I've just pointed it to my 19C trace directory here, sitting under the diag destination. Then I would create my alert log table. Now, as we know, inside the alert log, it's just one line for each log entry, and it can be anything, any piece of text. So my first attempt here would be something like this. Create a table called external alert. It's got a single column, varchar to 4000. In later versions of the database, I could make it varchar to 32K, just in case things get really wide, but I think there's probably not many alert messages in there in the alert log that are greater than 4K in width anyway. And then the rest is pretty much the same. Because it's just a single column with the entire text, I don't need any particular parsing in there. I've simply got delimited my new line to make sure that each row is a new row, or each line is a new row, and then just text from 1 to 4000. So very, very simple, and the location is the name of my alert log. When I query that, even just like that, I've got something useful now. Whereas I used to have to log on to the operating system and have a look through the alert log, now I can just query it with a simple query. Of course, inside the alert log is a lot of stuff, and the vast majority of it is just for information purposes. The name alert log perhaps is now a misnomer from bygone days. It's a lot of information now that might be useful, but the vast majority of it can simply be bypassed. So how do I dig into things of interest? In fact, if I look in my alert log, I've just grabbed some random snippets here from my alert log to see what we've got. And I might be interested in warnings that say, in this case, my virtual timer is drifting slightly. My poor machine's probably running too hot. Or I might obviously be interested in Aura 600s or any kind of Aura error that makes its way into the alert log. Generally, if an Aura error gets in there, it's something that's probably worthy of note. I might be interested when my temporary table space resizes. Someone's been running a big query that had to do some big sorting. I might be interested in file resize operations, etc., etc. I might be interested in pluggable database violations, or every time I start the database, one of the cool things that came along, I think probably about Oracle 12.2 timeframe, is we dump what patches have been applied. So they're always in the alert log every time you start up. So all those things are things that are sort of interest that I'd like to extract out of my alert log. And if I just have a single text column, then what I'm doing is writing a lot of text parsing. I'm doing substrings and in-strings and regular expressions and all sorts of things because I've just got the one column, which is 4,000 characters long. Doesn't seem to be any way I can avoid that. This is what I mean by external tables having even more flexibility than conventional SQL. A normal table has columns and you simply nominate where the data will sit in those columns. In an external table, those columns can be anywhere, they can even overlap. So I start with my text column of just 4,000 characters, and I'll keep that such that I can get the whole row should I want it. But if I dig into some of those things of interest that I was looking at before, if it's a warning, then the first 8 characters, I think, is the word warning. So I can actually have a column called warning, which is just the first 8 characters. Even though I've already got a column called text, which is the first 4,000, I can explicitly say I want a column called warning, which is just the first 8. If I get ORA errors, then it's going to be the first 9 characters of interest. So I'll have a column called ORA error. There's overlap in there, but it doesn't matter. I'll only want to reference those columns under particular circumstances, but we'll get to that later on. Similarly, for patches, I'll have a couple of columns looking for the word patch and the patch ID, which starts at character 11, should the first 10 characters be the name patch. And finally, if I'm getting resize operations, similarly, I can add some information there. So I've got the resize indicator from characters 1 to 6. If the first 6 characters are resize, then characters 35 to 39 are probably going to contain me the file number. That's probably large enough, unless I get to tens of thousands of data files, at which point I've probably got other things to worry about in this database. And also the thing that probably interests me most in any alert log entry is the timestamp, which is going to be the first 32 characters. You can see there on the first row on the text file there. That gives me an external table that now looks something like this. I've picked some other columns as well, but you can see you've got text, warning, ORA error, patch, timestamp, violations, etc. And all they are is different offsets in the same row for the external file. So how do I use this now? Well, it still requires a little bit of care, but now that I can reference those elements, I don't have to worry about things like substring and instring, etc. I can say, for example, when patch, which happens to be the first 8 characters, when patch equals patch ID, then I know I can reference the patch ID column. That's going to contain useful information. When the timestamp column starts with, say, 20, let's assume this database isn't going to last up until the year 2100. When it starts with 20 followed by a couple of wild characters, then a dash, then more wild characters, I could tighten this up if I wanted to, then I can safely run a to timestamp on there. I know that the timestamp in the alert log is always YYYY, MMDD, etc. So I can use the appropriate format mask, and that's going to give me a timestamp. Similarly for a resize, if the resize column, which is just the first 6 bytes, equals the word resize, then I know that the resize file will be out around byte 37 somewhere. I can trim off any trailing commas, and I'm good to go. Add the appropriate where clause. I can use a lag function using ignore nulls that will continue to hold the last timestamp encountered all the way down through the file. Add a few where clauses in, and there you go. I've got a timestamp for every single row, and I've got information populated as I see fit. I've got the patch IDs, when I had some Oracle errors, and when I had some file size resizes, etc. Obviously, as I stressed before, it's not as good as the real external table alert log we have, but this is more just an example of when you want to bring structure to a file in which there actually isn't much structure there. The alert log is a free format kind of file nowadays, but we saw it as an example here. You can actually apply structure by digging into various components. This is just the tip of the iceberg because I didn't even use some of the functions I could use inside the external table definition. I could, for example, use regular expressions, ltrim, rtrim, etc. to go parsing the information inside the external table DDL. And then after that, it would be even easier to extract data of interest from my file. So external tables can be very, very useful in terms of building some structure around data where there actually isn't much structure in the file. That's why I claim it's actually more powerful than actually just SQL itself. Now, a quick segue just while I'm talking about alert logs. Obviously, you can see the alert log is no longer a log of alerts. And in fact, if I jump onto my database here, you can see that after it's been running for a while, the alert log is, what's that? That's 300 kilobytes in size. In 21C, we've added a new file called the attention log, which you can see there is much, much smaller. Because what most DBAs do is they look through the alert log for things that are important to them, things that they should take some attention to. And in particular, given the alert log is got so much free format data in there, over the years, it's become quite difficult for a DBA to make that decision. Should I be paging someone based on what's in the alert log? Should I be calling them out of bed, say something's wrong? We've had to write very sophisticated parsing scripts to try to work out what's going on here. The attention log in 21C is our attempt to fix this. Every single row now is put out as JSON, and it's only things that are worthy of note. And what's more, we've made a classification on every single entry in there. So you can see the first one is I'm starting the Oracle instance, therefore it's only informational. We've got heavy swapping. Well, that's obviously something that requires some urgency. So you'll see this in 21C moving forward. Not only do we have the alert log, we now have this thing called the attention log in a nice structured format, and I think you'll get a lot of benefit there rather than having to write your homegrown parsing scripts from the alert log. But returning to the topic at hand, you can see now that the power of external tables lets you provide structure to unstructured data, and therefore I would argue that perhaps is even more powerful than all the tools you have available with SQL alone. External tables have always been good for dealing with flat files, but complications have started to arise. Now, what do I mean by file complications? I track it all back to this guy. Back in the day, an Excel spreadsheet was capped at 65,536 rows. Those of you that are students of the powers of two will know that obviously somewhere in there, there was some sort of integer limit that Excel was limited to, so 65K or 64K in reality was where the limit was at. This was a good thing because if everyone was ever providing CSV files to you, you knew that if they came out of Excel, they were going to be small, manageable files because Excel was capped at 64K. Of course, Excel being, I'd argue, probably the world's most popular database because every single person wants to drag data out of their beautiful Oracle systems or SQL Server systems or Postgres systems and dump them into a nice, unsecure, unprotected format called Excel. It's a sad thing. Excel, because of its popularity, got bigger. And I think probably about Excel 2007 onwards, somewhere around there, you can now put 1 million, or 2 to the power of, what's that, 2 to the power of 20 rows into an Excel spreadsheet. Once you get to 1 million rows, you're at that point where, as I point there, you really should have used a database. And in fact, well before that, you should have used a database. But as we go, people still use Excel. What this means, unfortunately, when it comes to external tables, is that we're no longer getting CSV files from people because the files are simply too large to manage. We start getting files that are compressed. In fact, the example here I've got here is a gzip compressed. There are other zip, gzip, etc. What happens when you put a compressed file as a source for an external table? Well, unsurprisingly, we're going to have some problems. We can see here, I've simply told the database to try read that compressed file. It's assuming just a nice flat format ASCII or UTF-8 file with obviously no compression. So when we try to read it, it's just going to reject all the rows. It has no knowledge or no inherent knowledge about the file format that's coming in besides what we tell it in the database. That presented a bit of a problem because the vast majority of data now, as it got larger and larger, was being provided to us in typically compressed format or some other particular format. The preprocessor option was invented back in Oracle 11 to solve this, and this is a really, really cool thing. The preprocessor is a command that will be run as your external table is processed, and it will be applied to the file in question. So here, if I look at my little batch file, I called it decomp.cmd. You can see it's just as a gzip minus DC. Minus D means decompress. C means put it through to standard out. %1 means take in the file name that's passed to it. The external table DDL will take this file name and pass it into as a parameter to the program that you've nominated as a preprocessor. So this will uncompress the file name that's passed. The C means pump it out as standard output. So the external table will read that standard output and use that as its input. So what this is saying is, here's my table, take my compressed file, uncompress it on the fly, pipe the output back to me. The database will then consume that output and put it through its normal external table parsing facilities. And as a result, I took a compressed file and now I can query it as if it was an uncompressed file. I never had to uncompress it physically and store it somewhere. It was uncompressed on the fly and sent into the external table parser. That's very, very cool. The file names will be passed as parameters. If an external table has multiple file names, they'll be passed in situ all the way along so you could access all of them. You do need to take care, a little bit of care with windows and paths. One of the things that people often get caught out with here with the preprocessor option is for security reasons. The database will launch that with absolutely no environment set, because we wouldn't want to pick up the standard Oracle environment because it's got access to the data files, etc. So you are in charge of explicitly setting what paths you need to pick up access to executables, etc. Generally, I fully qualify the path names just to avoid any issues. Similarly, under Windows, sometimes you need to set an environment variable called Windows root so the database knows where the Windows installation is. Check out that blog post I've got there, which tells you what you might need to do to run certain Windows commands. It's just an environment variable you need to set under Windows. The reading of files external to the database via external tables is really, I suppose, just the first step on a journey toward talking to the operating system. Probably the most common requirement is that we have some data, because it's a database, that's outside where we'd like to have it. Therefore, an external table offers a hook to it. But really, this is just a subset of the larger problem of I want to reach outside the shell of the database, so to speak, to get access to things that are only available normally at the operating system level. And historically, talking to the host or talking outside the database is a hard thing to do. And don't get me wrong, this is a good thing. The whole reason we have databases and database platforms is such that they are insulated from the operating system. It shouldn't be too easy from a database to go hooking into things in the outlying server, because it's the same reason why browsers don't have access to the file system on the PC you're running it on. It's a security risk. We don't want errant code in the database going out and just destroying things on the operating system layer. It's generally a bad thing. But we've always had facilities inside the database to do it, and this is what we used to do, probably in the earlier versions of Oracle, and you can still do this. If you wanted to, for example, run a host command on the operating system, which the database doesn't natively do, you would have to write some Java. Using the inbuilt JVM that comes inside the database from 8i onwards, so 25 years onwards, you could write a routine that has a create or replace in there, but you're actually creating a Java class inside the database. This is an example from AskTom, which basically implements a little Java utility to run a host command. It runs the host command that you pass in as a parameter, and then it spits out the output from whatever comes back from a standard out. So it's a bit of complexity, but you could run it. Rest assured, to get an idea of how much people want to talk to the OS from the database, that question and that answer on AskTom has over 50,000 views since we ever published it. So people want this facility. But the reality is, writing Java for most database professionals isn't generally their cup of tea. We write DDL, we write tables, we write queries. Writing Java inside the database is often frowned upon, and people have had problems with that routine as the JVMs have evolved over the years. It's just another layer of maintenance you have to take care of. But let's take a look at the preprocessor option for an external table. In this case, this is a simple one. I'm simply decompressing a compressed file. At which point people go, hold on a second. I wrote that host command. That wasn't some command that came in the database. I wrote that little batch program called decomp.cmd, which simply does a gzip minus, to uncompress a file. So if that's my file doing gzip, well, surely I can just ignore that and put any kind of programs I want, whether it's Unix shell or whether it's Windows command file. The moment the database is hooking out to an external program that is authored by myself, I can put anything in that preprocessor option, surely. And that's true. This is huge because this is now that ability for the database to, in a nice controlled fashion, get access to operating system facilities simply by the power of external tables. If you can script it, if you can script something up and put it in a batch file or a shell script, then an external table will be able to exploit it via the preprocessor option. Let's look at an example. What if from inside my database, I want to see how my server disk utilization is going? As DBAs, often we'll write routines to look at DBA free space, DBA data files, etc., to see how full our table spaces are getting, but that doesn't tell us how much they can extend by on the underlying file system because we don't know how full the disks are. But I can do something like this. First of all, I need an operating system command that will give me the information I want. So I could do something like a little script here called run-df, which unsurprisingly runs the df command and spits me out some information like that. Because that's just a command that gives me some output, that is something I'll be able to use as a preprocessor option to grab via a standard table. So we take another, we've got a file system, some blocks, used, available, capacity mounted on, and it's delimited out there. So let's now build that into an external table. Here's my external table definition. I'm going to call it df, remarkable imagination. We've got the file name, the blocks, used, available, capacity. They're just the normal columns. Now we need some way of hooking into that bash program we had. So I've got a default directory called execution directory. That's where my script is called. The preprocessor option is execution directory run df. I've chosen to skip one because the first line that comes back from my df command is just the headers, the file system, the used, etc. I don't want those tags because I don't need them. I just need the raw data. And when you nominate an external table must always point to a file that exists, otherwise you'll get an error. But in reality, I'm not really processing any files here. I simply need the external table definition in order to run the preprocessor option. So what I've done is I've nominated my location as the same name as the execution file, simply because I need some file that already exists, doesn't matter what it is, in order to have my external table definition correct. If I had an empty file called dummy.data, I could use that as well. By using the name of the executable option in my preprocessor, I know that that file must exist, otherwise I wouldn't be able to run my preprocessor option anyway. But then I query my table, and there you go. Literally via SQL and an external table, I now have the disk utilization. I could now do some comparisons between those file systems and my data files to get information about how well my system is traveling. But there we have a select statement which is actually running host commands. Let's look at another example now. UTL file, what I call the missing piece. If I do a describe on the UTL file package, which is the facility we use to do file input and output on the Oracle database, I can close a file, I can copy a file, I can get attributes for the file, the size, etc. I can open a file, I can remove a file, I can rename a file, I can put output to the file. It seems to have everything except the one thing I'd really like. If I'm dealing with files, what's the first thing you do when you're dealing with files? You want to get a listing of what files are there, and UTL file does not offer that. Maybe external tables can give us a hook here. So here is my run directory command. It's very simple. I turn off echo and I say directory of, I'm just going to do a listing of the Oracle 19C binary directory where all the executables are stored. If I run it, you can see it simply does output, typical Windows output, and I start listing out all the files in C Oracle Product 19 bin. So from an operating system point of view, that works just fine. Now I'm going to hook it into an external table. I create my table called directory listing. I've got fdate, ftime, AM, PM, because if I flick back a bit, let me flick back one slide, you can see that the PM, AM is actually a separate field to the time as well. So we've got date, time, AM, PM, and then the size and the file name. So I've got date, time, AM, PM, the size, and the file name. How am I going to parse that? I'm going to parse it using whitespace. So when I encounter some whitespace, that means move on to the next column. I'm only going to load the rows when the file size does not equal the dir. That way I'm going to skip over that header information and I'm going to ignore directory information. I'm just going to get a listing of files and their sizes, and I'm going to run my preprocessor option, run dir.bat. I'm going to ignore any rejections because the first few lines is just that header information which I want to ignore. So I've built my external table, and there we go. Now I can do a directory listing straight from inside the database. There is the listing of files in the C Oracle Product 19 bin directory. Very, very cool. The rebuttal to that obviously is that's just one directory. And the reason I put this example here like that is I think that's a good secure option to go with. We're about to see how we can do that for any directory, but I prefer this kind of operation by default. Have a fixed list of scripts that let people access just certain directories. That way you've got nice security and nice tight control. You probably don't want people being able to run directory listings across any single database directory on your server. It's generally not a good thing to allow. But if you do want to do that, if you're, for example, on a non-production box or a development box, we can exploit that a little bit further. I'm going to take my external table definition here, which currently has run.dir.bat and run.dir.bat, and tweak it. As we know, that file must exist, which is why I use the same file here as my preprocessor option. In that way, I know that file must always exist. But I'm going to change that to source directory.txt. That's going to be the name of the directory that I would like to run a directory listing on. That means I need some mechanism to actually write to that file, source.txt, the name of the directory I'm interested in. Well, that's easy. Of course, I've got UTL file for that. UTL file can do that. I can simply open up that file, write out that I'd like to do a listing of C Oracle Product 19 Network Admin to see where my TNS names files are, and then close the file. Once I've done that, I can now make a little batch script that says, print out the contents of source directory and run the dir command on that source directory. So I want to print out network admin, and there we go. Select star from directory listing, and I get listener aura, SQLnet.aura, etc. So lots and lots of power now being able to hook into operating system facilities. As long as they provide some sort of output, you'll be able to query that output via an external table. Once you get the preprocessor option in play for an external table, yes, the preprocessor option is designed to provide output to come as a result to your SQL query, but that doesn't prohibit it from doing all sorts of other things. Yes, this preprocessor option just does a directory listing and spits those directory listings out into the standard external table parser. But you could do a whole lot more. For example, one of the things DBAs are often challenged with is every time they want to apply a patch, it's often the case that OPatch, the software that is used to apply patches, has been updated or changed on the Oracle support site, and you have to download a new one. The most common time we find this out is when we run the OPatch command that says, I'm sorry, you can't use this OPatch command for this particular patch you've just downloaded. But what if an external table could be used to update OPatch, or in fact, do any kind of software updates on your machine? Really, it's just a case of having some smart use of what's in the preprocessor batch file. So this one has been designed for Windows, but you could easily modify it to work onto Unix as well. The first thing I'm doing is using my customer CSI number. I've commented about there and put user and password to go get the patch number for OPatch, which is, have a quick look, 6880880. If I get the patch.xml file, that's effectively a manifest of all the bits and pieces inside, including the version number for that particular patch. The second command there just knows that in the first 1,000 lines, it's probably going to be the particular version of OPatch I need for my particular platform. The XML file contains the definitions of all the different platforms for which OPatch is available. So I'm gripping out there for MS Win, trying to find the various bits and pieces, and I also can find the version number as well. And I'll make this script available on my GitHub repo as well, or you can check out my blog post on it. I then go find the current version of OPatch. So I just simply go to Oracle Home/OPatch, print out the current version. And the only real thing that the external table definition is interested in here is those four commands you can see there. All they are doing is outputting to standard out what the current details have in terms of the current patch version, what's available on support.oracle.com, etc. If they match up, that's the first line there on the script, I'm done. I don't need to do anything because my OPatch version is up to date. But if not, I'm just doing what I would normally do in an OPatch update. I would simply keep the old one in opatch.old, install the new one, unzip it, etc. But all I'm doing is putting all this into a script that can then be called from the preprocessor option in an external table. After that, I just create an external table as per normal using my preprocessor option. And once that's done, now simply with a query, I can actually update OPatch. This is the output that came back. I looked at my current version, it was 12.2.01.23. I reached out to MetaLink to get patch.xml for the particular OPatch patch number, and it said the available patch was 25, so it's more up to date. Because it saw that, it then reached out to MetaLink again, or Moz again, and downloaded the actual zip file and installed it by copying the old version into opatch.old and installing a new version. I'm not saying that every utility you ever build should have an external table sitting on top of it, but for example here, if you could do this now, once you've done this, you no longer need operating system access to keep your opatch up to date. This could be very useful in terms of being able to give this responsibility over to a junior programmer, junior DBA, etc. They're not going to need or require OS access, yet they can keep opatch up to date. You can see the possibilities here are endless when it comes to what you could pack into an external table preprocessor and give access to it from a simple query. If you check out my blog, you can see there's an example there where I can check if Apex patches are available for my Apex installation just by doing the same kind of process. You reach out to Moz, pick up the relevant XML files and dig into there, do a bit of data mining to find out whether you should be downloading fresh patches. Let's wrap up this session on external tables. So much more we could have covered, but time is against us. I think external tables are destined to take over from SQL Loader. I'm hoping the SQL Loader external table equals generate facility remains there because it's my go-to when it comes to generating external table DDL. But I think external tables, you can hopefully, I've proven to you that they have so much more power than just mere SQL Loader. In particular, I think the preprocessor option is certainly just a magic wand. It opens up so many opportunities now, and it increases the reach of external tables to well beyond what's inside the database and more than just reading files that sit outside the database. I suppose the key thing there when it comes to preprocessing is the fact that imagination is perhaps more important than knowledge. That's Albert Einstein. Let me know on Twitter or otherwise what you've come up with, what uses you've come up with for external tables. I'd be interested to see them, especially when you can hook in those preprocessor options. That's me done. Please follow me on Twitter if you want to keep up to date with Oracle technology. I'd love to hear your stories of external tables and your explorations, in particular those imagination kind of opportunities you have there with the preprocessor option. Most of the stuff you've seen today, the opatch stuff, the Apex patches, the Windows facilities for external tables are all on various blog posts of mine, so keep up to date there. Just search for external tables in the keyword search and you get all the posts there. And hopefully you'll see you on my YouTube channel at some stage in the future. Thanks for your time, everyone, and bye for now.
CloudDB, shaping your new normal.